Welcome to this beginner-friendly guide on understanding abstract classes, abstract methods, interfaces, and their practical implementation in programming. We'll explore these core object-oriented programming concepts step by step. Let's begin by exploring abstract classes, which serve as essential blueprints for other classes but cannot be instantiated directly. They provide a foundational structure without being a complete, usable object themselves. Think of an abstract class as a partially built car chassis. It defines common features like wheels and an engine, but it's not a complete, drivable vehicle on its own. It sets the stage for what a car should generally be. Its primary purpose is to provide a common base for related classes, ensuring they share certain characteristics and behaviors. This promotes consistency and reduces redundant code across different but related entities. Now, let's delve into abstract methods, which are declared within abstract classes but crucially lack in implementation. They are essentially placeholders for functionality that must be defined later. These methods act as a contract, forcing any concrete subclass to provide its own specific implementation for that method. This ensures that all derived classes adhere to a predefined set of actions. For instance, our car chassis might have an abstract start engine method where each car type implements it differently, like a gasoline engine versus an electric motor. This allows for diverse engine types while maintaining a common starting point. This ensures that all cars built from our chassis blueprint will have a way to start, even if the mechanism varies. It guarantees essential functionality across all concrete car models. Next, we introduce interfaces, which are entirely abstract and define a set of methods that a class must implement. They specify a contract for behavior without providing any implementation details. Unlike abstract classes, interfaces cannot contain any implemented methods or instance variables, only method signatures. They are purely about defining what a class can do, not how it does it. Consider an interface as a universal remote control. It defines buttons like power, volume up, and channel down, but doesn't specify how each device responds. It's a standard set of commands. Any device, be it a TV, stereo, or projector, can implement this interface, providing its own unique response to each button press. This allows for interoperability and consistent interaction across different devices. This allows for great flexibility, enabling different classes to adhere to a common standard of behavior. It promotes a plug-and-play architecture where components can be easily swapped. The key difference lies in their purpose. Abstract classes are for relationships, like a car is a vehicle, providing a base for inheritance. They establish a hierarchical relationship. Interfaces, on the other hand, are for or can-do relationships, such as a car can be driven or has an engine. They define capabilities or roles a class can fulfill, independent of its inheritance hierarchy. Now, let's see how to implement these powerful concepts with simple, clear code examples. We'll walk through practical applications to solidify your understanding. First, we define an abstract class, shape, with an abstract method, calculate area, and a concrete method, display info. This sets up a basic structure for geometric shapes. Notice how calculate area has no body, signifying that subclasses must provide their own implementation. This forces specific area calculation logic for each unique shape. Next, we create a concrete subclass, circle, which extends shape and provides a specific implementation for calculate area. This demonstrates how a concrete class fills in the abstract details. This demonstrates how circle fulfills the contract set by its abstract parent class. It successfully implements the required abstract method, making circle a complete, instantiable class. Now, for interfaces, we define drawable with a method draw, without any implementation. This interface simply declares that any class implementing it must have a draw capability. Any class that implements drawable must then provide its own draw method. This ensures that all drawable objects know how to render themselves. Let's have our circle class also implement the drawable interface. This showcases how a single class can adhere to multiple contracts. This allows circle to inherit properties from shape and also gain the drawable behavior defined by the interface. It combines both inheritance and interface implementation for rich functionality. By using both abstract classes and interfaces, we achieve a powerful combination of code reuse and flexible design. This approach leads to highly modular and extensible software architectures. Remember, abstract classes are about defining a common base for a family of objects, establishing an is-a relationship, while interfaces are about defining capabilities or contracts, representing can-do behaviors. Both are crucial for robust design. These concepts are fundamental for building robust, scalable, and maintainable software systems. Mastering them will significantly enhance your object-oriented programming skills. Keep practicing these principles, and you'll master object-oriented design in no time. Consistent application of these concepts will lead to elegant and efficient code. Thank you for joining us on this journey to demystify abstract classes, methods, and interfaces. We hope this guide has provided a clear and practical understanding of these essential programming tools.